Hey everyone, welcome back to another video by Camroom 5. So in this video we're going to be solving the May-June 2022 examination. So without wasting any time, let's begin. So let's say we are just doing a solution of this examination and without wasting time, jumping on question 1. Choose from the following compounds to answer the questions. We have multiple compounds here and we will talk about each one because we need to understand why we are choosing whichever compound we choose. Each compound may be used once, more than once, or not at all. State which compound is purple in color. We know which compound is purple in color, that is acidified manganate. By the way, we should also know that it's a strong oxidizing agent. So I will keep telling extra information even if it's not connected to the question for our understanding. So potassium manganate reacts with aqueous sodium sulfate to produce a white precipitate. When you see the word white precipitate and sulfate in the same sentence, you should be looking for something which has barium ions in it. Because barium ions, when they react with sulfate ions, both are in aqueous forms and you get barium sulfate precipitates. So barium nitrate here is your answer for this part. Reacts with aqueous chlorine to give a brown solution. Chlorine looks green in color. When it's in solution it's pale yellow or yellow in color, and when something is producing a brown solution comes because of iodine is actually brown in color. So let's look in the options where we can see iodine or something related to that. We can see we have potassium iodide here. Potassium iodide, which has Ki in it, when chlorine reacts with it, chlorine will displace the iodide, and chlorine will make potassium chloride, and iodine will be displaced. This is known as halogen displacement reaction, so Ki will produce a brown solution. It's prepared using a precipitation reaction. So we need to understand precipitation means solids and insoluble. So we need to look for something which is insoluble because only insoluble substances are made by precipitation. So our answer has to be some insoluble salt. Looking at the options, the first one makes most sense. Silver chloride is insoluble white precipitate. It's silver chloride. Contains an anion with a charge of -3. Which anions have a charge of -3? So either group 5 or you can say phosphate mostly fit here. So I don't see a phosphate here, but I will continue to look for it. Nitrate has a -1, sulfite is -2, manganate is -1, carbonate is -2. You can see sodium nitrite, which has sodium with 3 plus ion. Sodium with a charge. There are 3 sodiums basically, that's why 3 plus here. And nitrite is 3 minus. Remember to notice that each sodium is +1 times 3 because there are 3 sodiums, and nitrite is -3. So sodium nitrite has an anion with a charge of -3. Moving on, is used to test for a reducing agent. So test for reducing agent is adding potassium manganate 7, because only an oxidizing agent tests reducing agent. You cannot test a reducing agent with something which cannot oxidize it. So a good oxidizing agent is a test for reducing agent. So that is why KMnO4 is the best choice here. Moving on. The table shows some information about elements in group 6. When I see group 6, I already know they are referring to 6 valence electrons. State the electronic configuration of sulfur. From periodic table you can see that sulfur has an atomic number of 16 and atomic mass of 32. So configuration of sulfur becomes 2, 8, and then obviously 6. So we will write 2, 8, 6. Total 16 electrons. Predict the density of polonium. So for the density of polonium, I can see that polonium is in the end, and you can see the trend is basically increasing. You can see the density is increasing each time. So it's showing an increasing trend. I will ask myself, how much density has changed in the last bracket? So from 6.3 and 4.8, I can see, I will calculate that also. The change in density was 6.3 minus 4.8. It was a change of 1.5 units change. So I am very sure next time the same change will occur. So I will add 1.5 into 6.3 to predict, and my answer turns out to be 7.8. So I am saying my density change is likely to be 7.8. In the marking scheme, you have a range, but they never ask for a range, they expect an actual value. Sulfur has a boiling point of 445 degrees Celsius. Predict the physical state of sulfur at 200 degrees Celsius. One thing is very clear, the boiling point is more than 200 degrees Celsius. So it is definitely not a gas. But still, let's look for it. When you go for the melting point, you can see the melting point for sulfur is 113. So 200 degree is more than the melting point but less than the boiling point. So the prediction of state turns out to be liquid. It's a liquid compound. It's a liquid element or substance here. Why? Because melting point is below 200, so it's already molten. But boiling point is above 200, so it's not a gas. That's why it is a liquid. Oxygen exists as a diatomic molecule. Draw the dot and cross diagram for a molecule of oxygen. Only show the outer shell electrons. So I will pick a circle. Two atoms means two circles should be drawn like this. I will label each one as oxygen. Oxygen is group 6. It is group 6. So makes two covalent bonds each atom. Since there's only one overlap, they make two covalent bonds. Four lone, basically you can say four unbonded electrons. There's another word for it which is known as lone pairs, but we don't have to know that, it's in AS level. So you will have those unbonded electrons. These are unbonded electrons, also known as lone pairs. Explain in terms of structure and bonding why oxygen has a low melting point. So in terms of structure, I will say that it's a simple covalent molecule. The structure means simple covalent molecules. And then bonding or attraction means there are weak intermolecular forces between these molecules, and that should be enough. You can further say that these forces are easy to overcome. Easy to overcome forces. Moving on. Selenium is a non-metal. Deduce the formula of selenium 4 oxide. You can see selenium 4 means it's the oxidation state. Roman numbers means oxidation state. So selenium has an oxidation state of 4. Oxygen is always -2. So the answer for this turns out to be 4 and 2 are cancelled. It becomes 1 here, 2 here. So we write SeO2, selenium 4 oxide. A small sample of selenium 4 oxidized is dissolved in water. 2 drops of universal indicator are added to this solution. Predict the color of the universal indicator in this solution. Explain your answer. They have mentioned that selenium is a non-metal. When it's a non-metal, most non-metal metal oxides are acidic oxides, and since they are acidic oxides, the pH has to be lower than 7. So my color choice is going to be somewhere in the acidic range, and that is why I will either pick red or yellow. I do not know how strongly acidic it could be, so I can pick both answers, and your examiner will write only one, but both should be acceptable. My explanation is that it's a non-metal acidic oxide. It's a non-metal acidic oxide. So pH of my solution will be less than 7. Calculate in decimeter cube. Calculate the volume in decimeter cube of 30.2 gram oxygen at room temperature and pressure. So we know one thing, that volume is equals to moles times 24, because they have mentioned room temperature and pressure, so that is 24 decimeter cube. But how many moles are here? So mole is equals to mass over, since it's oxygen, we are talking about MR. 30.2 gram oxygen should be divided by 32, which is the MR. So number of moles turn out to be 0.944 for me. 0.944. These are the number of moles for me. When I multiply it by the 24 value, so volume turns out to be 0.944 times 24 decimeter cube, which gives me a volume of 23, or exactly 22.65 decimeter cube. They have mentioned two significant figures, so even if the answer is 22.65 decimeter cube, two significant figures mean first two non-zero values, so 23 decimeter cube. Remember, they want two significant figures, don't forget that. The diagram shows some reactions of butanoic acid. When butanoic acid was reacted with magnesium, you can see gas A and salt B were produced. When it reacted with magnesium carbonate, salt B, gas C, and liquid D. And then when heating with ethanol, you get liquid D and organic liquid E. Identify by names. So we need to write the names, not the formula. When a acid reacts with a metal, you always get hydrogen gas. So A has to be hydrogen gas. Which salt is produced when a butanoic acid reacts with magnesium? So magnesium plus butanoic acid should give you magnesium butanoate. Magnesium butanoate, and obviously hydrogen gas. So salt B is magnesium butanoate. When we talk about gas C, a carbonate will always give you carbon dioxide gas when you react it with an organic acid or any sort of acid. So you will get carbon dioxide gas here, carbon dioxide gas. When they talk about D, so liquid D and organic liquid E. When an organic acid reacts with alcohol, you get esters. So acid plus alcohol will give you esters plus water. Now what is liquid D and what is organic liquid E? Since they have already used the word organic with E, it has to be the ester, while liquid D is going to be water. So water is the liquid E. Name and draw the structure of E. Since they are already mentioning which acid and like the alcohol are here, we know the ethanol has 2 carbons and butanoic acid has 4 carbons. So we are dealing with ethanol and butanoic acid. So the alcoholic part is written first in the name. You will write ethyl. The organic acid part is written second. So you get ethyl butanoate. When we talk about the structure, first draw any part. Let's suppose I'm drawing the butanoic acid part, which is 4 carbon part. And then I'm drawing the alcoholic part, which is the 2 carbon part. Acidic part has the carbon double bonded oxygen left with them, and both are connected with ester linkage, which looks like this. Remaining portion should get hydrogen atoms on it, so I will draw the hydrogen atoms like this. The left portion represents the acidic portion, the right part of the molecule represents the alcoholic portion. Don't forget to notice that this is your ester linkage here. This is your ester linkage. Butanoic acid is a weak acid. State what is meant by the term weak in weak acid. So weak here means it dissociates partially. Weak here means dissociates partially in water. And obviously we know extra information added gives H plus ions. Even though it does not dissociate completely, but you do get some amount of H plus ions. The table shows information about some particles. State the nucleon number of bromine 3579. What is nucleon number? Nucleon number means proton plus neutron inside nucleus. Nucleon number is another word for atomic mass, by the way. So it is obviously 79 because atomic mass and nucleon number is the same thing. State the number of electrons in bromide 3579. It is anion. Anion means extra electrons. How many extra? So it has one electron more than protons because it has a -1 charge. So you will write 35 plus 1 is equals to 36. It has 36 electrons on it right now. Calcium 2040 is the full symbol for one isotope of calcium. Write the full symbol for another isotope of calcium. So isotope means same proton but different neutron. So make sure you write Ca, and 20 should be the same, but the atomic mass will be different even if one extra neutron is there. So one extra neutron makes it 41. Describe how a calcium ion is formed from calcium atom. So don't forget to notice it's a cation, and not just cation, it's a divalent cation, which means it has 2 plus charge. So it is made by loss of 2 electrons from calcium atom. Calcium bromide is an ionic compound. We know that because calcium is a metal, bromide is the negative ion. Calcium bromide conducts electricity when molten but not when solid. Explain why calcium bromide conducts electricity when molten but not when solid. So we will talk about the fact that it has ionic lattice, has tightly packed ions in solid state. The tightly packed ions in the solid state are there, which cannot flow freely. But in molten state, ions flow freely. So ions can flow freely when they are in the liquid state. Predict two other physical properties of calcium bromide. It's an ionic compound, remember? It's ionic. Since it's ionic, what do we know? It has definitely high melting and boiling point, so very high melting and boiling point. All the ionic compounds are soluble in water, so you can talk about solubility in water is present, or you can say it's soluble in water. That would also mean the same thing. Let's move on. Ethanol is manufactured by the reaction between ethene and steam. When you see the word ethene, you should know that it's an alkene with a formula of C2H4, and steam is obviously vapors of water. The condition used are 300 degrees Celsius, a high pressure, and a phosphoric acid catalyst. The reaction between ethene and steam is reversible. The forward reaction is exothermic. If the forward reaction is exothermic, the reverse reaction is going to be endothermic. If you have watched my video, you would know I use a word exotil here. Exotil for exothermic reversible reactions. An equilibrium mixture is formed when the reversible reaction happens in a closed system. Predict what happens to the amount of ethanol. What happens to the amount of ethanol in the mixture if the temperature is decreased? If the temperature is decreased and the pressure remains same. So exotil means in exothermic, temperature increase pushes the equilibrium to left. But the question is concerned about decrease. So temperature decrease will push the equilibrium to right. So you will say more ethanol is made. Why? Because the equilibrium is going to the right side. Because the equilibrium shifts towards the right side. Equilibrium shifts towards right side. Why does it shift towards the right side? Because when the temperature is decreased and the environment is becoming cooler, the reaction will try to retaliate by releasing more heat. When you decrease the temperature, the equilibrium feels the need to take charge and release more heat by itself. So you will say it will release more heat. More heat because the temperature was cooled by you, the temperature was decreased by you. So the equilibrium will feel the need to release more heat, and that is only possible through forward reaction. Predict what happens to the amount of ethanol in the equilibrium mixture. Again, they're concerned with the amount of ethanol. If the pressure is decreased, so for pressure we find the gaseous moles. You can see that on the left hand side there are 2 gas mole. On the right hand side there is 1 gas mole. When you decrease the pressure, it favors the side with more gas moles, which is the left side. So left side means equilibrium goes to left. Equilibrium goes to left means it will make less ethanol. Why? Because less pressure favors the equilibrium side with more gaseous moles. It's important word. Do not forget to write gaseous. It's important word here, which is the left side. So equilibrium is moving towards the left side. Describe. So describe is the key word here. Describe the manufacture of aqueous ethanol by the fermentation. Include equation, essential conditions. So equation, we know that when glucose is anaerobically respired, you get 2 moles of carbon dioxide in anaerobic respiration and 2 moles of ethanol, which is C2H6O. The conditions involve glucose to be mixed with yeast at room temperature, because higher temperature might kill the yeast. At room temperature, the absence of oxygen is really important here. In absence of oxygen, since they do not want pure ethanol, it's okay to not talk about distillation here. Ethanol will be later distilled, but it's not important to say here. Ethanol will be distilled later. Moving on, a sample of an alloy containing aluminium and copper is added to hot dilute sulfuric acid. What's an alloy? Alloy are mixtures of metals with other elements. Remember, they are talking about hot dilute sulfuric acid. Only the aluminium reacts with the dilute sulfuric acid. The products of the reaction are hydrogen and aqueous aluminium sulfate. So, aluminium reacts with dilute sulfuric acid. So, aluminium is Al, dilute sulfuric acid is H2SO4. The products are hydrogen, which is H2, and aluminium sulfate, which is Al2SO4 thrice. They wanted the ionic equation. I will cancel the ions and write the ionic equation in the same space. Aluminium has no charge. Sulfuric acid is basically H plus and SO4 2 minus. Your products are hydrogen gas, which is a gas, so we never write ions out of it. The other product involves aluminium ions, so Al ions with 3 plus charge on both of them, and there are 3 times sulfate ions. Now, what happens? You cancel the basically sulfate ions from both scenarios, so you get aluminium, hydrogen ions, hydrogen gas, aluminium ions. Let me write it somewhere here to show you what's happening. Aluminium plus hydrogen ions will give you aluminium ions and hydrogen gas. It seems balanced, but it's not. Charge wise, it's not balanced. So on the left hand side, you can see there is 2 positive charge because of both these, and to the right side you can see 6 positive charge because of these. How do we balance them? So we need to convert the hydrogen ions 3 times. So it will make it 6 hydrogen ions, and you will get 3 hydrogen gas molecules. So your final equation becomes, let me remove this all, or I can make it smaller for extra working. I will put it here. The final equation becomes aluminium, which was double aluminium, reacts with 6 hydrogen ions to make double aluminium ions and 3 mole hydrogen gas. When we talk about state symbol, aluminium was a solid metal. Hydrogen ions were in the aqueous acid. Aluminium ions are in the aqueous salt, and hydrogen was a gas. Describe a chemical test for aluminium ions. So we talk about sodium hydroxide and then aqueous ammonia. When you add sodium hydroxide, add dilute sodium hydroxide. What do we see? We see white precipitates are made, and the white precipitates remain soluble in excess. But for aqueous ammonia, they will not. So white precipitates upon few drops of dilute sodium hydroxide but dissolve upon excess. And when we talk about aqueous ammonia, white precipitate upon few drops aqueous ammonia but remain insoluble upon excess. The aqueous aluminium sulfate formed is crystallized to make hydrated aluminium sulfate, Al2SO4 thrice dot XH2O. The relative formula mass of hydrated aluminium sulfate is 666. Calculate the value of X in the formula. So we know Mr is equals to aluminium sulfate plus X times H2O. 666 is equals to aluminium sulfate's Mr. Let's calculate the Mr of this portion. It's going to be 2 times 27 plus, there are three sulfurs here, so 3 times 32 and 12 oxygens overall, so 12 times 16. When we do that on a calculator, we get that it's yeah, 342 units. So 342 because of the aluminium sulfate, and X times 18 because each water is 18 units. When we mathematically solve it, we get to know that the value turns out to be, let's solve it, 666 minus 342, which is 324, x 18 is equals to 324, and then we divide it by 18, we see 18 units, OMG. So it's 18 units of water with each hydrated salt. State what's meant by the term alloy. We have already talked about it. It's a mixture of metals with other elements. Remember, alloy could be a mixture with a metal or a non-metal, that really doesn't matter.